The first question for us to consider is, what is the title? This is something we heard in primary school, in secondary school, and is equally important in university and in life. What is the title? And you'll notice in our graph up here, there is no title. This is extremely important. You'll perhaps remember sitting tests in school and you were always told that the first thing you do on a graph is a title. And here we can see in this example, there is no title. And that's crucial because we don't actually know what the graph is showing. A title tells you what a graph is showing, which brings us to our second point. What is the date? Perhaps this is also something that could appear in the title. I mean, the first thing I noticed from this graph is the number 500,000 about confirmed cases. So I know that this graph must be from the past. That was my initial impression, because I remember hearing in the news how the United States, for example, had passed 1 million cases of COVID-19. So I know that this graph was some time in the past. However, without a title, we're not clear on that. It's extremely confusing with no title and with no date. These are essential. You must let people who are reading graphs know the precise information that the graph shows. If you don't do that, then things are open to interpretation. I might look at it one way, as I told you my first impression about there not being 1 million cases, so I knew it was in the past. People might think this is relevant for today, or a long time in the past, or it's not even about COVID-19. There's no title, and there's no date. And I had to check in the whole article, and there was no title for the graph anywhere. However, I should say at the start of the article there was a date. But I mean, that was quite far away from the title, quite far away from the graph, I should say. Every graph must have a title, and in graphs like this, there needs to be a date as well. Okay, next we'll come to what are the axes, or what is being measured. Our x-axis, down here, the horizontal line is days since 100 cases. And our y-axis, over here, excuse my arrows, or the vertical line is confirmed cases. This is very important because it lets you know what is actually being measured. Now, one very important thing to say is about the different scales. You'll notice that our x-axis, days since 100 cases, is linear. Let's see if I can spell with the mouse. And that means it increases in a normal way, 0, 5, 10, 15, 20, and so on. It's a regular scale. However, our y-axis, confirmed cases, is what we call a logarithmic, or a log scale. Look at the numbers, 100, 500, 1000, 5000. Now, the reason why we use a log scale is because it allows us to record extremely large numbers. If we were to include 500,000 up here, I mean, would be meters. My screen wouldn't be large enough. We'd need a huge graph. You'll notice that unlike linear, where the gaps are equally spaced, the numbers are equally spaced, 10, 15, 15, 20. There's a gap of 5 between both of them, and the distance is the same. In confirmed cases, what we have is the distance between 100, down here, and 1000, 1000 and 10,000, 10,000 and 100,000, 100,000 and a million is the same. Now again, if you don't pay attention to this, you will misinterpret the graph. So you need to know whether it's a linear scale or a log scale. Okay, next we'll come to what I think is the most important question. What isn't shown? Without a title, as I said before, this leads to very tricky waters because we don't know precisely what's being shown and when the data is from. For example, this graph does not show deaths. This graph does not show how many tests were carried out that led to the number of confirmed cases. This graph does not show the population. So for example, and I know it's in the past, some stage, we have United States, Spain, Germany, Italy, China, France, Iran, and the UK near the top over here in this section. Of course, the United States has a larger population than most of these countries, apart from China, which is the most populous country in the world. So this graph isn't allowing the lay person on the street to take into consideration that these countries have different populations, as well as completely different factors, other factors that impact on COVID-19. Also, another thing we don't know is how many days it took to get to 100 cases. Perhaps one of these countries got to 100 cases very slowly, and then they have accelerated after getting to 100 cases. Or perhaps a country got to 100 cases extremely quickly, and they've slowed down, which would, I suppose, be a sign of progress. This graph does not tell us about that. So you really need to, as I said earlier, take it with a pinch of salt. Another thing worth pointing out is there's an overload of information. Clearly, the United States is highlighted here in orange. And then we have these lines double every day, every 2 days, every 3 days, every week, and every 2 weeks. That would be the number of confirmed cases doubling. I enjoy that. That's this section, this one, and this one. I think that's useful. That explains in simple terms to a person who perhaps doesn't understand graphs. But then all this in kind of fine color, it's very difficult to interpret what's going on. You can hardly read the names of the countries. There's too much information. And then the last thing I will say about this is there's what I'm calling a complicated blurb somewhere in here. Average geometric growth, previous day 1.40 times growth. Now, you may know what average geometric growth is, you may not, but what does it actually mean in real terms? Would the normal person in the street know what these numbers mean? I don't know.